Good morning, student. Today we are going to start the new chapter, that is probability. Let us understand this chapter by doing one activity. Okay, in this box I am taking 5 red coins and 3 blue coins. Total number of coins are 5 plus 3, 8. Now without looking in the box, I am taking any coin randomly. Okay, I am getting a blue coin. So what is the probability of getting the blue coin? So total number of coins are 8. And how many blue coins were there? 3. So the probability of getting blue coin is 3 by 8. Let us write it on a blackboard. Total coins 8. Red coins 5. Blue coins 3. So what is the question may be like this. What is the probability of getting red coin? Now red coins are 5. So 5 divided by total number of coins, that is 8. So we say that for finding the probability, the formula is equal to number of favorable outcomes divided by number of all possible outcomes. So here total is 8 and the favorable, that is red color coin, are 5. So probability of getting red coin is 5 by 8. Now suppose the question is like this. What is the probability? Blue coin is equal to number of blue coins are 3 and the total number of coins are 8. So the answer is 3 by 8. Okay, now suppose if I put my hand in that box, and what is the probability of getting a green color coin? The answer is 0 because there is no green coin in that box. So the probability of getting any other color is 0. Now probability of any event is represented by PE and the probability of not event is represented by PE bar. Now here the probability of getting a red coin is 5 by 8. And what is the probability of getting not red coin? Not red coin means blue coin. So that is 3 by 8. Now suppose if I do the addition of 5 by 8 plus 3 by 8. That is addition of P of E plus P of not E. So I am getting 8 by 8 which is 1. So this is one formula to remember, that probability of an event plus probability of not event is always equal to 1. Now let us talk about impossible event and certain event, or we can call sure event. Suppose any event is going to be certain, or it is going to be happen certainly, it is sure. For example, sun rises in the east. What is the probability of it? The answer is 1. So such events which are universal truth and they are going to be there. So the probability of such event is always 1 and such events are called sure event or certain event. Now the probability of impossible event is always 0. For example, that event which is impossible, it never happened. So then its probability is 0 and such events are known as impossible event. So when the probability is 100%, that means the event is sure, it will happen definitely, then the probability is 1. And if it is impossible event, it never happened, then the probability is 0. One more thing. Now the value of probability always lies between 0 to 1. That means the probability never be more than 1 and never be negative. It lies between. If it is impossible, it will be 0. That means the probability will be equal to 0 or greater than 0. Or less than 1 or equal to 1. So the value of probability always lies between, that means it may be equal to 0 or greater than 0, or it may be smaller or equal to 1. So the value of probability is always between 0 to 1 or maybe 0 or 1. Exercise 15.1, question number 1. Complete the following statement, that is fill in the blanks. Question number first. Probability of an event E plus probability of event not E. That means is equal to dash. We had already discussed that it is always 1. Question number 2. The probability of an event that cannot happen is obviously 0. The probability of impossible event is always 0. Such an event is called impossible event. Such an event is called impossible event because it is not possible. See the third blank. The probability of an event that is certain to happen is 1 because this is sure event. Such an event is called certain event or sure event. And its probability will be always 1. Question number 4. The sum of the possibilities of all elementary events of an experiment is 1. Because if there are many elementary events, then their sum will be always 1. Question number 5. The probability of an event is greater than or equal to 0 and less than or equal to 1. So, the value of probability lies from 0 to 1 or between 0 to 1. If it is impossible, probability is 0. If it is 100% possible, probability is 1, and remaining values lies between 0 to 1. So this is our first question of exercise 15.1. Now let's discuss question number 2. Question number 2. Which of the following experiments have equally likely outcomes? First, a driver attempts to start a car. The car starts or does not start. Now see, when a driver starts a car, most probably it will start. Very few chances that the car will not start. So that chances are not equal. The chances of starting the car is the car will start. That chances are more. So this is not equally likely outcome. Okay, it will not have a equally likely outcomes because the chances that the car will start are more. Now the second is, a player attempts to shoot a basketball. She or he shoots or misses the shoot. Now, he is a player. So, the chances that he will shoot the basketball, that chances are more. By chance, he will miss it. So, here also, it is not equally likely. It will not have equally likely outcomes. Now, the third. A trial is made to answer a true or false question. Now, this is equally likely outcomes. Why? Because there are 50% chances of true and 50% chances of false. So, equally likely outcomes. A baby is born. It is a boy or a girl. So, there are again a 50% chances, a boy or a girl. So, it is also equally likely. It will have equally likely outcomes. Question number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of the football game? Why tossing a coin is because tossing a coin is have equally likely outcomes. Because it will either have a head or tail. Okay, so because this event have equally likely outcomes, therefore it is considered as a fair way to choose the team. Question number 4. Which of the following cannot be the probability of an event? The A is 2 by 3. So if I divide, I will get 6.66 and so on, which is less than 1. So it is possible. Okay, let's see the second option. The second option is minus 1.5. So not possible. Why? Because the probability never be negative. Not possible. So B is not possible. Now let's check C also. The C is 15%. 15% means 15 divided by 100. So it is 0.15. It is also less than 1. Okay, so it is also possible. And the D option is 0.7. So this is also possible because it is also less than. Be the probability of an event. So the correct answer is B. Minus 1.5 is not possible. So it is the answer of question number 4. Now let's see question number 5. Now in question number 5, the probability of an event is given 0.05 and you are told to find the probability of not event. We have to find this. Now we know that probability of event plus probability of not event is always equal to 1. So probability of event is already given, that is 0.05 plus probability of not event is equal to 1. So this comes to this side. So probability of not event is equal to 1 minus 0.05. So the answer is 0.95. So here probability of the event plus probability of not event is equal to 1. So it is given, probability of event is given 0.05. So this will come to this side. I will get the probability of not event which is equal to 1 minus 0.05. In exam sometimes they will give you this value. Find this value. So we will minus it. So the answer is 0.95. Thank you. Next time we will continue the next question.